All right. All right. Let's get started. So a couple of things coming up, or a couple of things just to announce. Wednesday review session, 4 to 6. That's about the only time that works for me next week, so I just figured I'd throw that as the time. I'll tape it, come by my office any other time throughout the week, but my evenings kind of stink next week. Hi. Okay. Let's see, what did I mention? Oh yeah, I did finish upgrading videos and practicals. So don't look now, I know everybody's going to, but the grades are up. I will hand back stuff next week. Now for the practicals, I'm going to give those to you guys in lab on Wednesday, but I need them back. Those are the only tests throughout the semester that I end up keeping, okay, because I like to look at some stuff there for a while afterwards. So I'll hold on to those, but you can come by and look at them at any point. And then I'll give back the grade sheets for practicals, or not practicals, I'm sorry, for the videos on Wednesday as well, or Monday. I'll give them to you on Monday in class. Exam Friday. And then the last thing to point out is that as we move into this last quarter of the semester, you may have noticed there's this like 3-day period where we have student presentations. That's what it's listed as right now. Just to kind of give you a heads up of what that is. 5-minute presentations, you don't actually even have to stand in front. You can videotape the whole thing. It can be a voice thread. It's going to be you and either 2 or 3 other people. And what that means is then we're going to switch groups one last time. But you get to decide your own groups this time. Okay? So you can be in a group of 3 or 4, decide as you want. If anybody wants to be a free agent and be picked up off the wire by anybody, I will put up a free agent board and you can join whichever groups you want to that are looking for extra members. Okay? So, and we'll talk more about that particular project. I'll save the conversation on it until after the exam. You'll have a full day in class to work on it before we get to them. All right. Any other questions right now? Okay. So I thought the comments and conversation around the TED Talk was really good. I really appreciated the energy you guys put into it and the work you put into it. What I wanted to do first was just cover some of the kind of revisit a couple of the basic concepts here of antibiotic resistance on a bacterial population level, and then we'll spend the rest of the day kind of discussing those questions that I brought up in the homework assignment. The main goal, if you're keeping notes for, wrong way. Main goal for today, the second one. Discuss the social practices that end up leading to antibiotic resistance and how those practices select for resistant strains. So, focus on the right-hand side up here for this first one. What we're looking at here are examples of, well, in this case here, this would be on a population scale. We've talked about how bacterial populations, though we think every cell in a tube is identical to each other, same genetic information, there is variability. And that variability just comes from rising different mutations that come up spontaneously. In what we can find are cases where those ones that are resistant will survive an antibiotic treatment and then be the ones that repopulate the remaining culture. Okay? We talked about how we can kill microorganisms by treating them with a minimal inhibitory concentration. Actually, sorry, not kill, but actually inhibit the growth with those minimal inhibitory concentrations. Let's take a look at this in a more realistic light. Oftentimes we find that treatments will occur where a sub-inhibitory concentration is actually being taken. And we'll go through a couple of examples of this in a minute. But in those cases where we have suboptimal concentrations, we need to take a look at cell by cell, what is the minimal inhibitory concentration for each of those cells within a bacterial population. And if we were to chart every single cell and determine what is the minimal inhibitory concentration, we'd see something like this, normal distribution, where in that population there are some that are very sensitive, the majority of them are relatively sensitive, and then you have a few in every population that is more resistant than the rest. Okay? So if we were to treat, let's say, with a concentration that is subinhibitory, that doesn't kill the whole or that doesn't inhibit the growth of the whole population, which of those cells are going to be inhibited? So I'll put labels on here, too. Oh, great Googling, Mowgli. There's the answer. I give up. Just call it a day. Well, anyway. Bear with me. My apologies. All right, anyway, as we were saying, disregard the past 20 seconds. I'll delete it from the video later on. If we had, let's say, 1, 2, 3, 4, 5, 6, 7 micrograms per milliliter as the MIC, and let's say that we treat with, I don't know, no, 5.6. 5.6 micrograms per mil. All organisms that are inhibited by 5.6 micrograms per mil of this antibiotic or less will be inhibited in their growth, right? So, in other words, all of these will be inhibited. Which ones survive? The ones that are above that MIC. And what happens, and what we oftentimes see is that with suboptimal concentrations of antibiotics, those cells end up, oh, now you work, repopulating and become the majority population. And so as a group, you see a shifting in this minimal inhibitory concentration. That's what's contributing to the resistance. Okay? Is that general theme connecting a little bit more, better? What are examples, or what are times in which we might find that the amount of antibiotic is less than ideal? And think of this from a clinical standpoint. In which cases do those occur? Or how in our own lives, what might contribute to antibiotic resistance? Overusing it to an extent, yes, and we'll come back to that one. What else? What was that? Using it when you don't need it. What else, Zach?
I took tetracycline once for 3 years straight, and it didn't take me off of it, so now they said that it'll never help me again.
We got to talk about that one.
They forgot that they left me on it or something.
My good Lord, so we have to talk, but we'll talk.
Once a day for 3 years, yeah.
All right, so that's obviously overuse, but we'll come back to that one. Who's taken antibiotics for less than the prescribed amount of time? All right, you take eye drops for like 2 days, and then you stop, and then either it's good or it comes back flaring. And this is an example of that. That's suboptimal. Okay, the guidelines for the amount that you're supposed to take and the amount of time that you're supposed to take it is designed to kill or to inhibit the growth of all the microorganisms, so that your immune system can fight off the infection. But if you provide antibiotic for a shorter amount of time than what's needed, it's not necessarily going to inhibit every single one of those microbes, or it's not going to allow your immune system to catch up and kill the remaining ones. And that's where we can get some of these shifts. So what are other examples like that one, where you might take less than what you are required to over the course of an infection? Anybody reuse antibiotics? I have same kind of scenario, okay? I'm preaching but not practicing what I preach, I suppose, today. So if you have antibiotics that are sitting in your bathroom cabinet for, let's say the expiration date was 3 years ago, the amount of actual active antibiotic in that pill or in that eye drop, whatever it is oftentimes less than what originally was there. So if it's listed as 10 milligrams of penicillin, well, if you've let it sit around for 3-4 years, it's probably closer to about half that concentration. That's another example of these suboptimal conditions. Okay, so those types of conditions can lead to a shift in this population, and there are plenty of other ones as well. Low dose exposure to particular antibiotics over long periods of time, overuse, misuse, and we see other examples outside of even human health as well, and we'll try to cover a few of those today. This was put by the CDC a couple of years ago, and the World Health Organization just came out with a very similar list. They kind of classify microorganisms as those that are urgent, serious, or concerning based on antibiotic resistance and health concerns or pathogenicity of these microorganisms. So if you take a look at the urgent, what's the first one listed on there? C. diff. That's Monday's conversation. Okay. So C. diff, because it has the ability to sporulate, because we find that there's an increasing frequency of resistance to antibiotics like vancomycin, it's considered an urgent one. Okay. Other ones up there, the carbapenem-resistant Enterobacteriaceae, or CRE, those would include Klebsiella pneumoniae, E. coli, what's the other one I'm thinking of? Those are kind of the major two that are associated with resistance to newer generation beta-lactam antibiotics. Okay, so in the video, Maren McKinnon talks about, I think she uses the term KPC at one point to describe the spread of one bacteria, not only nationwide but worldwide. KPC stands for Klebsiella pneumoniae, I think it's either carbenicillin or carbapenem resistant. And the two of those drugs work very similarly to one another. Okay. Under the serious, we've got one that probably everybody has heard of, our meth-resistant Staph aureus or MRSA. And there's some other ones in here. We've also got ones like Candida albicans, which is a fungal infection. Okay, and so we find that these threats not only are bacterial, but also are fungal. And of course, in the case of Candida albicans or something like that one, it's not an antibiotic we're using to treat it, it's an antifungal, but it's the same idea. It's a selectively toxic drug. And then under these concerning, we've got Versa, erythromycin, streptococci, etc. One of the things that's kind of the common theme with all of these is that it has an antibiotic resistance in the name, okay? And so the ones that we were most concerned with are, of course, the ones that we find are resistant to multiple different drugs. Sometimes the term or the abbreviation that's used is MDR for multi-drug resistance. Okay. All right, so what I wanted to do next, I'm just going to kind of skip to the end here. What I wanted to do is have you guys break into groups of 2, 3, 4, and I'm going to try something a little bit different than this morning. First, I'm going to say what I want you to do is to pick one of these questions, and using what was put up by your group on the wiki and with what you have coming to class, try to come up with, take all that information and come up with the one best response you can to answer these questions. Okay, or come up with a list of information that you can use to help support your answer. But before we do that, because this morning they spent like 5 of these 10 minutes talking about anatomy and physiology, no surprise, I'm going to give you guys 2 minutes to talk about whatever the hell you want to. All right? So, and then you got to rein it in, and we're doing 8 minutes talking about this.
Wait, what are we talking shit about today?
Oh, it's whatever you want to for 2 minutes, all right? So you got till 1:17. Go. Huh? So for the let's talk antibiotics again. All right, so what I want to do is just to kind of walk through each of these then, and we'll use this as kind of an open discussion. We'll end with a couple of questions at the end, but I just want this to kind of largely be a discussion on that video. And I mean, honestly, if you guys want to bring in personal examples, C. diff, for example, we can talk about that. I don't have any problem with it. All right. So let's just start with the first one then. What arguments does Marin make to support her argument that we're reaching the end of the golden age of antibiotics? Go ahead, Jaden. Why not? What does she use to support that argument?
Yeah. So, bacteria are becoming more resistant. I don't know about it, to be honest.
Thank you for your honesty.
I did watch it.
I didn't say you. Oh, it did Sarah say? Yeah. Is she swearing at you too? My gosh.
Oh, people are dying. People are dying. That's what she said.
She did say that. Sid, what's the number? 700,000.
And then 2050, it's going to be
10 million by 2050. All right. So another way to put this, if you were to look at the 10 illnesses that caused the most disease in the 1920s, so before penicillin, and you were to look at the 1990s and look at the 10 most common causes of disease, what you find is there's this switch. Before, probably in those top 10, I think 5 or 6 of them were bacterial. Now it's down to like 2 or 3 of them. And it's not just because of antibiotics, but nowadays it's the heart disease, it's cancer, it's could probably, I don't know what else we would throw on there necessarily. Alzheimer's and dementia, maybe neurological diseases of some sort. But the type of diseases that individuals die from now has drastically changed. What else has contributed to that? It's not just antibiotics. In what way agriculture? Oh, I was thinking top 10 diseases still, but okay, sorry. How the hell is agriculture contributing? Okay. All right, why else are we out of the golden age?
We stopped making new ones.
And I'll just put here time from discovery to clinical use, probably. What else? No other evidence? That's it? In what way? Yeah, I gotcha. Or at least our ability to detect that resistance it seems to make it seem that it's quicker now than it was. And that could just be from the usage of it as well. Absolutely. Any others? Why don't we talk about that one? Let's jump to that one, because I think that kind of hits on So she brings up a couple of things. How might companies and researchers be engaged? What does she bring up as potential solutions or
She
ways?
says offer incentives.
Offer incentives in the form of
Grants
money. Money makes the world turn, right?
and Nobel prizes.
Nobel.
Okay,
There
she
is-
didn't say
there-
Nobel. She didn't say the Nobel specifically.
I just want to point out.
Just Nobel Prize.
Can I sidetrack for a minute and tell a quick story?
Yes. Whatever.
No, I'm laughing at you because this has happened to me. Okay?
No, I'm not confused.
No, I didn't say you were confused. That's happened to me too. All right, so when I was still at St. Norbert, they started doing this People of St. Norbert, like they do this People of New York for Facebook.
Yeah.
So I got asked to do it, and I was saying that I know I'm never going to win the Nobel Prize. I hope one of my students does. They never showed me what this was going to look like when it went out, like they had typed it up. And so they put that what I said was, I hope my students win the Nobel Prize instead of the Nobel Prize. So it became a running joke for a while. But. All right. Apparently you guys don't find it as fucking hilarious as I do. Whatever.
Well, when I win it, I will pronounce it
Noble.
right.
All right, so prizes, patents, Nobel Prizes, etc. Sid?
Shouldn't like an incentive be that like if they don't make an antibiotic, they're gonna die too? Possibly.
You would think so, right?
No, we want money.
So let me be cynical for a minute. What do pharmaceutical companies care about?
Money.
Money, right? So what do you think are the most profitable drugs on the market right now?
Opiates.
I do not disagree.
Is that true?
Morphine.
What else? Okay, morphine as an example. What else? Chemo? Yeah, I wouldn't disagree with that one at all.
She said Adderall.
What
That
else?
works too.
Huh? Adderall?
Oh, okay.
Oh.
I was joking.
I don't know if that's how you spell
I don't
Adderall.
know. I tried spelling it last night.
Any
I
others?
wish I was kidding.
Any others that should be on this list?
Yeah, I didn't know.
They call my
Yeah, and I knew.
No. What's so for ones like for these two in particular? And what is true about Adderall and chemo? Maybe what do they have in common? They are expensive. That's true.
Side effects?
People who are
Not so much. Don't think of why would a drug company want to invest the time and energy and money into making these? And one is the profits, but the profits come from a deeper issue.
People need it.
One is a need. Yeah, absolutely. I mean, if for some chemotherapeutics, if you're not put on the drug, you're dead, right? Haley?
Problem's just gonna keep growing. I'm like,
That's true too. I think that, and we do see that with cancer, is that there is an increase in prevalence because we're living longer, right? Adderall, probably because we more easily diagnose and it more often gets prescribed now than it used to. Jaden?
Sometimes they're harder to make generics for.
Sometimes they're harder, and sometimes that's because of patents and protection from patents. Let me include one more to this list. I'm not sure if this is the most profitable, but I'm going to guess that it is pretty darn profitable over somebody's lifetime.
Insulin. That's very true.
but I didn't
Why?
know it would be.
Why?
People need it.
Because they need it. If you don't take it, you die, right?
Right.
Here's the other way to think about it. You have a repeat customer. One of the goals of business is to get repeat customers, people who want to come back, right? And so with insulin, you have, if you are a type 1 diabetic, you have somebody from childhood that is reliant on that drug for the rest of their lives. There's a ton of money in that, okay? What is different about an antibiotic?
You don't need it all the time.
You don't. You need it for the time of the infection and then maybe the next time an infection occurs. So the price, the amount of money that you get from it is, over time, is not as profitable.
Yes.
You don't get to make as much early on with it being protected by patents in the same way that you would with some of these other drugs. Okay. I mean, if you think of the drugs that are most popular these days, they include ones that are based on psoriasis. They include ones that are based on heart medications, helping men with erectile dysfunction. Okay, those are the most popular drugs out there right now. All right, so because why? You've got repeat customers. All right. There's a lot of correlation here between how drug companies and pharmaceutical companies look at antibiotics and how they look at vaccines as well. What's true about vaccines?
They hurt.
Well, yes. Maybe I should rephrase this question because that's very broad. What is true about the amount of money that a company might get from vaccines?
Vaccines are expensive.
They are expensive, that's true.
But it should be only a 1 or 2 time.
Bingo. You've got somebody who's coming around once and hopefully, if it works properly, never comes back again. That's the design. It's a preventative method. And so again, because of that, you only have a limited number of individuals that are going to get it, and then once that population has been served, realistically, theoretically, should no longer need that vaccine, right? So because of reasons like this, there's a lot of argument that this is why we're experiencing gaps in the creation of antibiotics, gaps in the creation of newer and better vaccines, is because the profit isn't there. The other thing to point out here is the amount of time and the amount of money that it takes to even get a drug onto the market in the first place. So for a lot of drugs that are new on the market right now, we probably discovered them before you were born. Probably 20 years ago for some of these drugs. And it takes about 15 to 20 years from the initial studies of a drug in a research laboratory to taking it into a mouse model, to then taking it into maybe another animal model, but then to take it through 3 trials on humans. Phase 1 tests what are the side effects. How much it kind of starts to determine things like, are there negative side effects? 2, you start to figure out more about dosage. How much do you actually need to block whatever you're trying to block, or to turn on whatever you're trying to turn on? And then finally, 3rd is you get as many patients as you can possibly into that study and study the short and long-term effects. Sometimes there's a phase 4. So like HPV vaccine, I'm pretty sure HPV vaccine right now is on a phase 4 trial where maybe right now data is finally starting to roll in terms of understanding how many potential cases of cervical cancer or head and neck cancer is being stopped by that vaccine. So those phase 4 don't necessarily involve a lot of money, but they involve a lot of energy in terms of following up with patients. So the money that goes into drug development, it's front loaded. It takes a lot of money early on, and because of that, these companies are looking for big payoffs in the end. Zach, go ahead.
It's not really even the pharmaceutical companies though, because you can't get prescriptions or antibiotics unless you have a written prescription from your family doctor.
That's a really good point.
So,
You're absolutely, at least that's true in the U.S.
Yeah.
Not true everywhere, but you're absolutely right. So I guess I'm talking from the perspective of the reason why we have this gap in not having new ones comes from the cost that goes into developing these. But if you're talking about problems with the rise or with the spread of antibiotic resistance to any single drug, that happens after that drug has hit the market. And that's where we start to talk about some of these other features. So let's go to that. All right, so what kind of practices are leading to antibiotic resistance? So let's start with where you left off, Zach.
I think that if you go in for an appointment because you have symptoms of, cold symptoms or flu symptoms, they're always quick just to give you an antibiotic. Where I know, like my doctor.
Yeah, some are, some are not. It kind of depends on who you have.
Yeah.
I totally agree with you on that.
And if you take an antibiotic, for the same antibiotic 4 or 5 times within a year because you have the same symptoms, by the time 10 years down the road, it might not work.
Yeah, and the reason why it doesn't work again is that selection of. I mean, let's say it's a chronic infection. We talked about a case on Wednesday where the patient had chronic infection of Pseudomonas aeruginosa. They cleared it. They at least visibly cleared the infection with drugs, and then it came roaring back. If you continue to treat with the same antibiotic over and over again, that antibiotic over time will become less effective. It takes more of it to kill whatever bacterial infection it is. One of the ways that they kind of try to avoid that these days is switch it up. So like, let's say they give you ampicillin for an ear infection, it goes away, but you get another one a month later, they might move you to a different beta-lactam antibiotic, or move you to something outside of that class, maybe like a chloramphenicol or something like that. So that's one way that they can try to combat it, absolutely. What are other practices or other things that we see daily that are contributing to this? Jaden?
Patients are quick to jump to conclusions and want antibiotics.
Yeah, and I think that this kind of goes in hand with the cold. I mean, I don't know about you, but I've heard of horror stories of people going, I have a cold, I need antibiotics right now. And if any of you have seen the joke on my door, Batman slapping Robin, and in the middle of saying that he's got a cold and he needs antibiotics, and Batman's response is, it's a virus. Antibiotics don't work against viruses. Okay, so prescribe antibiotics that are for the infection, bacterial infection. I want to go a step further with this though, and one of the things we're going to talk about on Monday is talking about narrow versus broad spectrum antibiotics. What do those terms mean again? Broad spectrum versus narrow antibiotics. Yeah, so they're targeting different types, right? So like a broad spectrum antibiotic is targeting gram-positives, gram-negatives, maybe mycobacteria as well. Narrow spectrum, one of those groups. In an ideal world, we would want the most narrow spectrum antibiotic we can have, so that it affects the specific pathogen but doesn't have an effect on what we would consider to be mutualistic or beneficial microbes. And we'd want it to be as specific as possible so that mutations and selection occur only within that pathogen, but not to bacteria that are just receiving collateral damage from the antibiotic we're using to treat. Okay, so spectrum plays into this as well. What other features? Nancini?
Plays into why we develop antibiotic resistance.
Say that again?
Are you talking about the question?
Yeah.
I was gonna say she talked about how we put it in a lot of food, and that we're kind of overkilling our use of antibiotics because we pump it into meats because it fattens them and it protects them from like the really ugly conditions animals live in.
Yeah.
And we also put it on like fruits and vegetables.
Yeah, so I mean, there's a double-sided, with cattle in particular, livestock, what was found is antibiotics were a growth promoter. And I don't know if anybody totally understands the reason why. I think part of it is the organism, the cattle or livestock then is less likely to become ill, and that allows for growth. I think there's something beyond that, I'm just not sure. So the USDA has been cracking down on this. United States Department of Agriculture has been pushing, we need to take the antibiotics out of the farms. Farms, my postdoc advisor has spent his life studying livestock and E. coli and antibiotic resistance, and like if you were to ask him, he would say farms are the most prevalent source of antibiotic resistance. You get a lot of transducing phage as well that will move antibiotic resistance markers from one species to another in those types of environments. So absolutely, I think that's a big part as well. And the effect isn't so much on us because, and the reason why I point this out is, unless you're eating that ground beef raw, or unless you're eating chicken raw, which is disgusting, it's not going to have much of an effect on you personally. Because remember, antibiotics are heat sensitive. When you cook those food items, that's going to, at least on the meats that we talk about, that's going to inactivate those antibiotics. The effect really is what's happening on the farm and the spread of antibiotic resistance on those farms. And before you cook those meals, the spread of those potential pathogens to your household as well. So basically anywhere from farm to market. Okay. Other factors that we haven't talked about. Emily.
In high school, we through a class, we talked about hand sanitizer. And I can't remember the specifics of it, but there's something in the hand sanitizer that causes a huge problem in antibiotic resistance. I don't know if you know about
What did we talk about earlier this semester?
Cheerfoot or something.
Triclosan. That was the one.
Triclosan.
Yeah, so triclosan, I mean, there was resistance. What we find with some microorganisms is not only do they gain the resistance to triclosan, but actually you get cross protection to other antibiotics as well. We definitely did see that. Absolutely saw that. I think it comes down to practice in some ways, right? I mean, there's the clinical side of it. It's easy to say the doctor shouldn't be prescribing as many antibiotics. We'll come back to that in a minute. And a more practical side, it comes down to things like to stop the spread, there are logical steps. What do I ask you guys to do when you leave the lab? Or what does John ask you to do? Wash your hands. Purpose, to stop the spread of microorganisms from in the lab to outside of the lab. So as you are going from one patient room to another, to stop the spread of, for example, C. diff, wash your hands, okay? Simple measures like that can stop the spread of antibiotic resistance. It doesn't reverse the resistance that's already there, it just stops the spread of it. One of the areas that I think there needs to be more focus is in terms of what I would call rapid diagnostic tests. Who's had a rapid strep test done? Okay, leave your hands up for a minute. Leave them up. Of those of you who have had them, how many of you have had ones where it was negative on the rapid test but came back positive on the second test? So a lot. I think the rapid strep test sucks, and that's just my personal belief.
Swab of the throat.
Yeah, because it's like a 15-minute test, and it's supposed to be 80% effective. I don't believe it for 1 second. It's not. So part of the problem, and still, some doctors will put you on antibiotics right away, regardless of what the results to that test are, right? And they'll say stop taking them if the secondary test comes back negative, or stay on them if that secondary test comes back positive. I think where we need to invest time and energy not only is with new antibiotics, but rapid tests. Tests that would allow us to determine within 15 minutes with high efficiency or a high rate of positive predictive values, what kind of infection do you have? So let's say you come in with a cut that is oozing. Wouldn't it be nice to actually know what is causing that infection within 15 minutes of going into the hospital? And if we could do something like that, that would improve our ability to decide what is the best antibiotic to treat this infection. We could start to pick very narrow spectrum antibiotics instead of using broad ones to just treat what looks like an infection and we don't know exactly what it is. So the cost of those rapid tests and having them be highly predictive, very good predictors in whether you are positive or negative for an infection, are where I personally think we need to kind of invest some of that energy and financial support in order to better help combat antibiotic resistance. But that's just my soapbox for the day. Okay. Let's finish up with one question, just to kind of cap. All right, so it's just this bottom one here. Patient with streptococcal sore throat takes penicillin for 2 days of a prescribed 10-day regimen. Because he feels better, he then saves the remaining penicillin for some other time. After 3 more days, he suffers a relapse. Discuss the probable relapse, or discuss the probable cause. And then, secondary question, what would you tell this individual to do next time to maybe prevent this from happening? I'll give you like a minute to talk about it. It shouldn't be too challenging, but take a minute and then we'll discuss.
What's like a probiotic we do when you take it?
So, yeah, that's a great question. So probiotic, and will you actually remind me to bring that up on Monday? But the idea of probiotics are like lactobacilli. So the idea is if you take a broad spectrum antibiotic, that normally wipes out the natural bacteria inside the gastrointestinal tract. If you supplement with a probiotic, it helps to restore that. So like you would be killing anything that's in there but trying to restore it with like a natural microbiome again. That's the idea. That would, theoretically, yeah. All right, so let's just cap this real quick. So what's the probable cause of the relapse?
There were antibiotic resistant.
Yeah, or at least the amount that he took didn't kill off the full infection, okay? And then probably, I'm going to guess, the answer here for the second part of what do you tell him to do? Take the antibiotics for the full prescription, okay? So that problem right there, it's not necessarily a challenging one, but it kind of highlights the major things that we talked about today. I've been thinking about how to incorporate this section into the exam. There's probably going to be an essay question, a short one, but do kind of go back over what we talked about today in relationship to those specific questions about how does this spread? Why are we not in the golden age? And just take some time to think about what we've talked about. It's possible one of those questions shows up, okay? All right, with that, have a good weekend. I'll see you all on Monday.